this video, we will talk about the inspiratory flow rate and the two methods to get the inspiratory flow rate. First, let's identify what is the inspiratory flow rate. So it's measure the speed, how fast a person can breathe, and measure the volume of air moved in or out per minute. So the abbreviation for the inspiratory flow rate is VI and is measured in liters per minute. So this is a combination of two units. Liters, it measures the volume of the gas, and also minutes, it measures the time. So if we use liters divided by minutes, we will get the rate or speed of the inspiratory flow. And you might see some other unit combination, for example, milliliter per second, or liters per second, or milliliter per minute. Again, this is the combination of volume and the time. So you can combine any two of them to get a unit, but the standard unit for VI is liters per minute. And in order to get the VI, there are two methods. The first method we're going to use to precisely calculate what is the inspiratory flow rate using the VT, which is the tidal volume that measures the amount of gas moved in or out. So the unit of the standard unit of that is liter, divided by TI to get the speed of it. So the TI is measured in seconds. Why? Because per breath, it took only maybe 5 seconds for total, so it will be very short. So we will use second to measure the time period for the inhale or exhale. And divided by that, we will get the rate, but if you pay attention to the units, you will see liters per second instead of liters per minute. But what we want is liters per minute, so we will multiply 60 seconds over minutes. Only in this way we can cancel out the seconds with second and get the unit in liters per minute. In this way, finally we will get the unit as liters per minute. So this is the first method to calculate what is VI. Let's talk about the second method. This is for estimation. If we have the value for minute ventilation or minute volume, we can base on that to calculate the inspiratory flow rate. First, let's talk about what is the minute ventilation. This is the amount of air exchange in 1 minute. So the amount of air measured in liters, and it moves in 1 minute, so that's per minute. The unit of that is liters per minute. So we have the VE as minute ventilation and minute volume. Then in order to get the VI, we should know what's the relationship between VI and VE. As from practical experience, VI is 3 times VE. The reason is for the full breathing cycle. Inhale, it took 1/3 of the full cycle, and exhale, it took 2/3. One inhalation, that will be 3 times faster than the full cycle. For example, the total breathing cycle is 3 seconds, then the inhalation, it will be 1 second, and the exhalation, that will be 2 seconds. So the speed here will be faster because for the amount of air moves, it will be the same. The air get in is equivalent to the air get out and equivalent to the air exchanged in one cycle. Let's look at one example. For one breathing cycle, it combined with 1 inhalation and 1 exhalation. Because the inhale only take 1/3 of the time period, so that means for this action, it takes shorter time and the rate will be higher. For example, if there's total 6 liters of gas exchanged, then the average in this 3 seconds, that will be 2 liters per second exchanged. And for this part, for the inhalation, that will be 6 liters get in, and then divided by 1 second to get 6 liters per second. So for this one, we have 6 liters per second for the inhalation. And for the exhalation, that's 6 liters per 2 seconds, that's 3 liters per second. So you will see the airflow rate will be different for the full cycle, for the inhalation and for the exhalation. But what we want is the relationship between the inspiratory flow rate and the VE, the minute ventilation. So in this, compare with this two, we will have VI as 3 times VE. So we've introduced the two methods to calculate the inspiratory flow rate. The first method is to precisely calculate what is VI, use the measurement from VT, which is the tidal volume, and the time period for the inhalation in seconds, and then multiply 60 seconds over a minute to get the VI. The other method we introduced is from the estimation. From practical experience, one full breathing cycle contains 1 inhalation and 1 exhalation. So for the inhalation, it takes 1/3 time period of the full cycle. So that's why VI is 3 times faster than VE. So now let's verify if we can get the same answer using the two different methods. So first, let me introduce this RRR. Here is respiratory rate. So it measures how many breaths happen in 1 minute for a patient. So in this case, our example here is 12 breaths in 1 minute for this patient. And for the minute ventilation we measured for the patient is 12 liters per minute. Based on the ventilation, actually we can use the second method to get the inspiratory rate. VI, that would be 3 times VE, that is 36 liters per minute. Right, so this is from the estimation. Is there any way we can use the first formula here? We can base on the respiratory rate here to calculate that. So based on exchange, that is in, that is out. So for the amount of air exchange, that's equivalent to the air in, and that's equivalent to the air out. So total that will be 12 liters per minute. 12 liters in 1 minute, and then 12 liters for in and 12 liters for out. To get the tidal volume, so now if you look at this, we have the exchange that's equivalent to in, equivalent to out. So that's 12 liters exchange, the 12 liters in and 12 liters out, but that happens in 1 minute. Remember, if we want to get the VT, this is per breath. So the final unit of that will be liters per breath. Liters per breath. Liter on the top and then breath on the bottom. To get this unit here, we can first obtain this 12 liters per minute. That's the VE, right? The minute ventilation. And to cancel out this minute, we can use the RR here, which is 1 minute. We can put that on the top, and then in 1 minute there are 12 breaths, so 12 V here. Now we can cancel that out to get 12 liters per 12 breath. So reduce it, we will have 1 liter for a breath. So this part for each breath we can remove that. So VT would be 1 liter. What's TI? Again, we first need to obtain what's the full cycle of, what's the time period for a full cycle. If we have this 12 beat per minute, that means for 1 minute it will have 12 breaths, and then for each breath it will take 60 seconds over 12, that will be 5 seconds. For each breath it will take 5 seconds. And then what's TI? Remember, TI is the time period for inhalation. So that's 1/3 times 5 seconds. So it took 5 over 3 seconds. So for the TI, that's the inhalation period. So 5 over second. So TI is 5 over 3 in this case. And now we have the VT and TI. We can use the formula VT over TI times 60 seconds over a minute. So VT in this case is 1 liter, right? And then TI is 5 over 3 seconds, and then times 60 seconds over minute. Now we can reduce them by using 60 over 5 over 3, and then the unit is liters per minute. So now we can reduce this part, divide by a fraction that's times its reciprocal. So now we have 36 liters per minute. So if we use the second method, we also can get this 36 liters per minute. If we use the estimation, we also can get this 36 liters per minute. Now we can verify that both methods can give us the correct value. In some cases, if only VE is given, then use the estimation here. So if VI and TI are given, if VT and TI are given, you should use the first method.